Lesson 1.2, Solving Linear Inequalities. Lesson 1.2, Solving Linear Inequalities. Objectives: solve one-step inequalities, solve two-step inequalities. Inequality symbols. Top left is less than, top right, greater than. So bottom left is less than or equal to, and bottom right is greater than or equal to. Graph each inequality. Top left, x is less than 2. 2 is not included, so it's an open circle, and less than is going to the left. Top right, x is greater than 2. Still doesn't include the number, so there's an open circle, but we want the bigger numbers greater than 2, so we're going to the right. Bottom left, x is less than or equal to 2. So we're still going left, but now the 2 is included, so it is a closed circle. Greater than or equal to 2, x is greater than or equal to 2. So it includes the 2 and everything greater than it. New vocabulary. Set builder notation. Label the parts of the set builder notation below using the phrases given at the left. Show the set on the given number line. So that first part, we say all numbers B, and that vertical line is such that, of course, you probably know B is less than -6 would be that last part. So we would read that. The set of all numbers B such that B is less than -6. So -6 isn't included, it's an open circle, and less than would be going to the left. We are to use set builder notation to write the expression of the solution set for the inequality that is graphed. We can use whatever letter we want. I'm using X. So on that number line, that's the set of all values X such that X is greater than or equal to 2. The next one, it's the set of all values X such that X is greater than 5. It's not colored in, so it's not equal to. The last one is the set of all values X such that X is less than 2. Addition property of inequality. For any real numbers A, B, and C, if A is greater than B, then if we add C to both the A and the B, then it's still a true inequality. A plus C is greater than B plus C. If A is less than B and we add the same number to both sides, it's still a less than. Same with subtraction property. For any real numbers A, B, and C, if A is greater than B, we can take away the same thing from both sides, and it's still going to be greater than. If A is less than B, we can take away the same thing from both sides, and it's still a less than. Solve an inequality using addition or subtraction, then graph the solution set on a number line and give the answer using set builder notation. So the first step in solving this inequality is to get rid of your 4y. So subtract 4y on both sides. You get -3 is less than y plus 2. Get rid of the 2 by subtracting 2 on both sides. You get -5 is less than y. We usually write it so the y is on the other side, but when we do that, we have to flip our inequality sign. Since it was -5 is less than y and it's open to the y, when you switch sides, it still needs to be open to the y. And with the y on the left, it tells you which way you are going to shade. So, open circle at -5, and we're going to the right. It's the set of all values y such that y is greater than -5. Here's another one. Let's solve this. I would subtract 5x on both sides. We get x minus 2 is less than 7. Add 2 to both sides. X is less than 9. There's no switching sides or anything. That is A. And in set builder notation, it would look like the set of all values x such that x is less than 9. So now we have the multiplication property of inequality and the division property of inequality. Multiplication property of inequality and the division property of inequality. The rules are very much the same, but it depends on the sign of C. If C is positive, if A is greater than B, then if you multiply both sides by a positive number, then AC is greater than BC. Same thing with the less than. Same thing with division. If you're dividing both sides by a positive number, it's when it's negative that things have to change. So if A is greater than B, then AC is less than BC because we multiplied both sides of the inequality by a negative sign. So we have to switch our inequality to make it a true statement. Same thing if we were dividing. If A is greater than B, but we divide both sides by a negative number, we have to switch our inequality sign. And there's some numerical examples to the right. Solve an inequality using multiplication or division. Graph the solution set on a number line and give the solution set using set builder notation. So to get the P alone, we need to divide both sides by negative 0.3. But since we're dividing both sides by a negative, we're going to have to switch our inequality sign. We'll get negative 40 is less than or equal to P, but we want the P on the left. So switch everything. And we have P is greater than or equal to negative 40. Because of the equal to part on our graph, the negative 40 will be solid, filled in, and we're going to the right. Set builder notation is a set of all values P such that P is greater than or equal to negative 40. Example 2, guided practice. What's the solution to negative 3x is at least 21? We need to divide both sides by negative 3. When we do that, we need to switch our inequality sign. So x is less than or equal to negative 7, which is B. We need to graph the solution set on a number line and give the solution using set builder notation. This is a multi-step inequality. The first thing we need to do is undo that dividing by 2. So we need to multiply both sides by 2. When we simplify the left-hand side, we get negative 2x. On the right-hand side, the 2's cancel out, and you get x minus 7. Get all the x's on one side. So let's subtract x on both sides. We have negative 3x is greater than negative 7. We still have not multiplied or divided both sides by a negative number, so we do not switch our inequality sign, but now we are. So divide both sides by negative 3. We're going to have to switch our inequality sign from greater than to less than. And when we simplify negative 7 divided by negative 3, we get 7/3, or as a mixed number, x is less than 2 1/3, because that's how the number line is set up. So it's not equal to, so it's an open circle. It's less than, so it's going to the left. And we have the set of all values x such that x is less than 2 1/3. What's the solution to this one? Multiple choice guided practice this time. Now we need to get rid of the dividing by 3. So multiply both sides by 3. On the left, we get negative 6x. And on the right, the 3's will undo each other. So negative 6x is greater than x plus 5. Get the x's on one side. Negative 7x is greater than 5. But we need to divide both sides by -7, which means we're going to have to switch our inequality sign around. And 5 divided by -7 is -5/7. And that would be option B. Solving linear inequalities. Pandas. An adult panda bear will eat at least 20 pounds of bamboo every day. Write an inequality that expresses this situation. Give the solution using set builder notation and graph on a number line. So the inequality, at least 20 is 20 or more. So P is greater than or equal to 20. Set builder notation is a set of all values P such that P is greater than or equal to 20. Because it's equal to 20, our circle is solid and is greater than, so we're going to go to the right. Example 4, consumer cost. Javier has at most $15 to spend today. He buys a bag of pretzels and a bottle of juice for $2.59. If gasoline at this store costs $3.39 per gallon, how many gallons of gasoline to the nearest tenth of a gallon can Javier buy for his car? Here's our plan. We're going to write an inequality. Let's first of all set up our variable. X is going to be the number of gallons of gas that he buys. First part, the cost of the pretzels and juice was $2.59 plus the cost of the gasoline was $3.39 for every gallon. So it's $3.39 times X is less than or equal to, because he's going to buy or spend at most $15. And then we have our $15. Well, let's solve. So we're going to solve the inequality. It's right there for us. First thing we need to do is to get rid of the $2.59 from both sides. So let's subtract that. We get $3.39 times X is less than or equal to $12.41. Divide both sides by $3.39. We'll get X alone. We did not divide by a negative, so we don't have to switch our inequality sign. And X is less than or equal to 3.7 gallons. So in our set builder notation, it's a set of all values X such that X is less than or equal to 3.7. Rental cost. Jeb wants to rent a car for his vacation. Value Cars rents cars for $25 per day plus 25 cents per mile. How far can he drive for one day if he wants to spend no more than $200 on car rental? So there's one fee he pays once, that's the $25, but then it is 25 cents per mile. Our variable is going to be our number of miles. So $25 plus 25 cents per mile needs to be no more than $200, so less than or equal to 200. Get rid of your $25, subtract it on both sides. We get 25 cents times N must be less than or equal to $175. When we divide each side by a quarter, because that's what 25 cents is, M, the number of miles, is less than or equal to 700, which is another way of saying up to 700 miles. Define a variable and then write an inequality for the sentence and solve. Give the answer using set builder notation and graph the answer. So 20 less than a number is more than twice the same number. Here's our variable. I'm going to use N. So N minus 20, that's what 20 less than a number is more than twice the same number. So there is the inequality. Let's get rid of the N. We'll have negative 20 is greater than N. And let's flip our sides. So N is less than negative 20. There it is on our number line. It's an open circle because negative 20 is not included, but it's less than, so we're going to the left. Set builder notation. Set of all values n such that n is less than negative 20. Here's another one. Define a variable and then write an inequality for the sentence and solve. We're given the set builder notation and we're graphing it again. 4 times the sum of twice the number and negative 3 is less than 5 times the same number. So we're doing 4 times the sum. Sum is addition. Twice a number, so we're doubling n. So our variable is going to be n. And we have 4 times the sum, so that's why it's in parentheses there, of 2n plus a negative 3 is less than 5n. We need to distribute. We'll get 8n minus 12 is less than 5n. Get the n's on one side. I'm going to move the 8n, so subtract 8n on both sides. We get negative 12 is less than negative 3n. Divide both sides by negative 3. We will get 4 is greater than n, or if we flip it around, n is less than 4. So it's a set of all values n such that n is less than 4. And when we graph it, it's an open circle at 4. It's not included, and we're going to the left. Interval and set builder notation. The solution set of an inequality can be described by using interval notation. The infinity symbol below are used to indicate that a set is unbounded in the positive or negative direction, respectively. So the one there on the left, that's positive infinity, that's when you go to the right. And that next symbol is negative infinity. That's when you keep going to the left. To indicate that an endpoint is not included in the set, a parenthesis, either the left part or the right part, is used. Parentheses are always used with the symbols positive infinity and negative infinity because they do not include endpoints. So there's a graph. It's of x is less than 2. So an interval notation is going all the way left, keeps going to negative infinity. So we're going to start with a parenthesis and negative infinity, and then we're going to go up to 2, but the 2 is not included, so that is also a parenthesis. Here's another one. A bracket is used to indicate that the endpoint negative 2 is included in the solution set below. So there is our graph. The inequality is x is greater than or equal to negative 2. So the lowest value is negative 2. So we start with that, but there's a bracket because it's included. And we keep going to the right, which is going to positive infinity. And since we can't ever quite get there, we use a parenthesis at the end. In interval notation, the symbol for the union of two sets looks like that. It's a mathematical symbol. It's not a U. It's a mathematical symbol. The compound inequality of y is less than or equal to negative 7 or y is greater than 1, written in interval form, is, so we have a negative infinity, comma, negative 7, but we have a bracket because the negative 7 is included. And then we have the union sign. 1 is not included, so there's a parenthesis, but we keep going to the right to positive infinity. Graphing that. That's the left part. That is from negative infinity to negative 7. That's the part where y is less than or equal to negative 7. The other part is from 1 to positive infinity. Interval and set builder notation examples from page 20, 1, 3, and 16. Write each inequality using interval notation. So there it is in set builder notation. So we have the set of all values a such that a is less than or equal to negative 3. Since we're going less than, we're going to start with negative infinity. And we're going to stop at -3, but it is included this time, so there's a bracket. In number 3, we have a compound inequality, so we're going to need our union sign. The first part is y is less than 2, so we're going to start at -infinity, go to 2. 2 is not included, so we have a parenthesis. We need our union symbol. And the next part is y is greater than or equal to 14. 14 is included, so there's a bracket, and we just keep going higher towards positive infinity. Graph each solution set on a number line. So we're starting at -infinity, so we're going to be going to the left, and it stops at the right at 4, and it's included because there's a bracket. Okay, so there's a closed circle at 4, and we're going to the left. Lesson 1.2, Solving Linear Inequalities Assignments. Lesson 1.2, Skills Practice Worksheet is in Google Classroom. Submit the completed assignment in Google Classroom in the Classwork tab. It's a 5-point minor grade and show all appropriate work. Textbook assignment. Page 20, number 2 and 4 through 17. Submit the completed assignment in Google Classroom in the Classwork tab. It's a 5-point minor grade. Show all appropriate work.